Hi, welcome to my video on parallel proportion triangle theorem. Parallel proportion triangle theorem is known as PPTT. P parallel, P proportion, T triangle, T theorem. If a line intersects two sides of a triangle and is parallel to the third side, the line divides the two sides proportionally, that is, in the same ratio. Well, let's take the triangle that I have drawn, ACE, and draw a line through two sides parallel to the third one. So we'll say that BD is parallel to CE. BD is parallel to CE. And if that's so, we're saying that the line divides the two sides proportionally. So that means that BC over AB is equal to DE over AD. So this segment, AC and AE, are divided into two parts, and this is the ratios that are equal. So let's do the proof for this. Well, number one would be you're given the triangle ACE and BD is parallel to CE, and that's what we call a given. And as a result of that, we end up with angle 1, angle 2, angle 3, angle 4. So we end up with angle 1 equals angle 2, and angle 3 equals angle 4. Notice I put numbers here for this angle because I didn't want to go A, B, D. I called 2 because I didn't want to go A, C, E. Putting the numbers in makes, you don't have to name the angle with 3 letters then. So the reason that these angles are equal is called a PLT, and their corresponding angles equal. If you have two parallel lines and there's a transversal, these are corresponding angles equal. Corresponding angles equal with this transversal. And based on having two pairs of angles equal, we have the triangle that's going to be ACE, similar to triangle ABD. And that's what we call A similarity. We have two angles of one triangle congruent to or equal to two angles of another, then the triangles are similar. Now that means that we have, if I draw them over here, we have the big triangle, which is ACE, and we have the small triangle, which is ABD. These triangles are similar as you see them, so that means that I can put AC over AB is equal to AE over AD. And that's, triangles are similar, so that's the property of similar triangles. If two triangles are similar, then their corresponding ratios are equal. And as a result, let's see, we have to try to get, notice that this proportion, these proportions here, if you read across, you got B, C, D, E. They don't form a triangle. So these are not coming out of similar triangles. So I have to do it another way. So I come up with this way to do it. So AC is equal to AB plus BC. And AE is equal to AD plus DE. And that's what we call the segment, SEG, addition, ADD, property. And that was done. This property was discussed in congruent triangles. Look up the congruent triangles and you see this property. As a result, I can now take the AC here and replace it with AB plus BC. Over AB. And I can take AE, which is right here, and replace it with AD plus DE. So notice I'm taking these two and substituting right here and here to come up with this, and that's what we call the substitution property. Because I'm substituting in. Substitution property. And as a result, now I can take these two and go AB over AB plus BC over AB. So what I'm doing is taking this numerator and dividing both of these segments by AB. And the same right here, I can take AD and divide it by AD and take, is that right? D as a D, E, D, E, and divide it by AD. So both of these are being divided, and that's the properties of subtractions, the property of fractions. So if I have these two equal here, then AB over AB, so if I work backwards, they have the same denominator. Because they have the same denominator, I can add these together over the same denominator. So I'm reversing it now with property of fractions. And notice that AB over AB is 1. And AD over AD is 1. So that's a division. Division of equals. If two numbers are divided by each other, we get 1. And notice now that both of these have a 1 each side, so I can subtract the 1. So BC over AB equals DE over AD by subtraction. That's the subtraction property of equality, or some teachers just say subtraction. So notice we did prove the triangles congruent and did these segment addition and along with the substitution, and this we now have proven that the sides are divided proportionally. So another way to think about that, so that's the proof of that theorem, but let's think of it at another way. Just watch. Also, if I'm going to use it, if I make this line parallel to this one and I put a 2 and a 6 and a 3 and a 9, what we're saying here is that 6 over 2 is 9 over 3, because this line is parallel. So this line is drawn to these two sides parallel to the third side, so it divides the sides proportionally. But also, if you think about it, the lines, you can also go 2 over 6 equals 3 over 9. Still, notice 6 over 2 is 3. 9 divided by 3 is 3. Or we can go 2 over 6, which is 1 over 3. 3 over 9 is 1 over 3. So when you have parallel lines drawn to two sides. These two lines are parallel to each other. You can either go 2 over 6 is 3 over 9, or 6 over 2 is 9 over 3. So if you have the triangle and you have these two lines parallel, and you have A, B, C, D, you can either say A over B equals C over D by P, P, T, T, or you can say B over A equals D over C by P, P, T, T, because they're the same ratios. But most people will go A over B equals C over D by P, P, T, T. They normally don't name it this way, even though I've done the proof doing the reverse. But most people will go with A over B equals C over D as a proportion. So that's the proof for PPTT. Let's do some examples. An example, I have a triangle, and with this line is parallel to this, so therefore x over 12 is equal to 4 over 6, P, P, T, T, parallel proportion triangle theorem. So 6 times x equals 12 times 4. 6x is 48. Divide by 6, and I get x is equal to 8. So x is 8. And 4 over 6 is the same as 8 over 12. Another one, we have these two sides of these two sides are parallel to each other in this triangle. So we have proportionality. So we could say that x plus 3 over x plus 1 equals 15 over 12. And if we cross multiply, 12 times x plus 3 equals 15 times x minus 1. So x plus 3 times 12, 15 times x plus 1, 12x plus 36 equals 15x plus 15. And 12x minus 15x equals 15 minus 36. And that gives us, that's a 15 there. So that gives me negative 3x equals negative 21 divided by negative 3, and x equals 7. So 7 is the number that makes the proportions true. So we put a 7 here, you get a 10. Put a 7 here and you get an 8. So 10 over 8 is the same as 15 over 12 when you reduce them. Practice means, now pause the video and see if you can work this answer out. When you get it done, press play to see if you're right, and then pause the video again to see if you're going to do this one correctly. So here we go. We got a triangle, two parallel. This line is parallel to this one, so it divides the sides proportionally. So 2x over x minus 4 equals 10 over 3, and that's the parallel proportion triangle theorem. And cross multiply, so 2x times 3 equals 10 times x minus 4. 6x equals 10x minus 40. And 6x minus 10x equals negative 40. Negative 4x equals negative 40. Divide by negative 4, and x equals 10. And again, if you put a 10 in here, 10 in there, so x is 10, so 2 times 10 is 20. Put a 10 here, 10 minus 4 is 6, so 20 over 6 is the same as 10 over 3. Notice the 20 over 6 reduces to 10 over 3, so it's true, so 10 is right. Or if you cross multiply, 60 equals 60 is true. And let's work this one. Again, pause the video and work this answer and press play when you're finished. We want to find AT. AT, what length is it? But to do it, we have to say that x plus 4 over 6 is equal to x plus 6 over 10 by PP, parallel proportion triangle theorem. Cross multiply. 10 times x plus 4 equals 6 times x plus 6. Multiply 10x plus 40 equals 6x plus 36. Notice the 10 is multiplied by x and 4, and the 6 is multiplied by x and 6. 10x minus 6x is 36 minus 40. Variables on the left. When they move, we change the sign. Numbers on the right. When they move, we change the sign. So 6x becomes negative, plus 40 becomes negative. So 4x equals negative 4. Divide by 4, and x is negative 1. Now, we have to get what AT is. Remember, AT is x plus 6. So negative 1 plus 6 is 5. And it sounds funny to have x as negative 1, but let's see if this is true. So let's put negative 1 here. Negative 1 right here gives me a 3 over 6. Negative 1 here gives me a 5 over 10. And notice, if you multiply, cross multiply, 3 times 10 is 30. 5 times 6 is 30, so it's okay. Or if you reduce it, you get 1/2 equals 1/2. So it's true. So x equals negative 1. Correct. The length of AT is 5. Correct. So I deliberately made this a negative, but it still fits the problem. If this was a negative number and you plugged it in, or if you plugged this x value, so if you took this x value, whatever it was, and plugged it in right here, and it made this length negative, then the value of x wouldn't work, because you can't have a triangle with a negative length. And let's continue. Now we're going to do some proofs with the PPTT. Let's see what we have here. We have a B, C, E is a trapezoid. And it says that this line, HTX, now I named this with 3 letters to show you that was going on through, is parallel to, and I got parallel to, it should be a BC. Oh, I forgot to change that when I was doing a correction. That's BC. Oh, my mistake. Everything is okay. Everything is okay. I was saying BC, but I had it parallel to AE. So everything is all right. So that line is parallel to AE. There it is. Mark it in. Now, look at this proportion. BHCX. This is not a pair of similar triangles. HAXE is not a pair of similar triangles. So we have to come up with another way to do this proof. And let's see what we have. BH over H, BH over HA. That's dividing the side proportionally. Notice XC over EX. That's this one to this one. That reminds me of the, PPTT. So notice that BH over AH is in this triangle right here, AEB, and CX and EX is in this triangle, EBC. But both of these triangles have this as a common side. So we might have to look at BT over TE being equal to these two. So, because it's not similar triangles. So here we go. Let's see. How do I get it? I know that this is parallel to this. Okay. So I'm given that HTX is parallel to AE, and that's a given. That means that BH over HA equals BT over TE, and that's in triangle ABE. That's the PPTT. In this triangle, these are parallel lines, so we got this ratio. So that's number 1. This is number 2. Now we need to get the parallel lines here. But what happens is that we have a trapezoid. So I have A, B, C, E is a trapezoid. Now, why did I give you a trapezoid? Because in a trapezoid, the bases are equal. Sorry, the bases are parallel, not equal. A trapezoid has the bases parallel. So it has only one pair of parallel sides, and that's these. And that's the definition of a trapezoid. P-E-Z. My spelling is atrocious. Definition of a trapezoid. So now that we have, these are parallel, so we have, notice that AE is parallel to this one. HTX, AE is parallel to this one. We now have AE parallel to BC, so that means that HTX must be parallel to BC. All three of them must be parallel, because if two lines are parallel to the same line, they are parallel to each other. And again, that's in the incongruent triangles proof that I did. So what we're talking about is all three of these lines are parallel. And as a result of that parallel, we have, because this line is parallel to this one, that means I have BT over TE is equal to CX over XE. And the reason is that's in triangle EBC. This triangle, this is parallel to this, so that's PPTT. And hence, if we look at it, that's BT. Notice that BT is right here. I'll draw BT over TE. This is BT over TE. Just look at them. There they are right there. So since this ratio has BT over TE and this one has BT over TE, that means that BH over HA must be equal to CX over XE. And that's what we call, you can say, transitive property. It's the transitive property. Or you could say substitution. Both of these proportions have BT over TE. Therefore, this ratio must be equal to this ratio. And that's the proof on that. Again, dealing with the idea of a trapezoid with opposite sides parallel, giving you two PPTTs. And now we have another proof to do, but this one is a practice. Practice means pause the video, see if you can work this one out. So pause the video and see if you can work this one out. When you get it done, press play to see if you're right. Here I go. Now I have to look at that YA is parallel to WT. Angle 1 is equal to angle 2. So how is these parallel lines in this angle going to give me XY, XYA? Is this a triangle? XYA. XYA is a triangle. And YWAY. And YW, oh, that's not a triangle. So how am I going to get it? So there's a triangle here, XYA. Let's see, XYA is a triangle, but the bottom is not. So I can't get it with similar triangles. So when I have these parallel lines, I remember I have what? Well, let's see. I have as the given. So these lines are parallel. Notice I got x, y, and yw, and I got an xa. Almost proportional, but I don't have at. So if I had xy over yw and xa over at, I would have a pptt. So what's happening? I don't have an at, but I have an ay. If that means that ay is probably replaced with at, or at is replaced with ay. So let's see. If these two angles are equal, that means these two sides are equal. AY is equal to AX, converse of the ITT, isosceles triangle theorem, coming out of the congruent triangles section. So, okay, here we go. So I have this one equal to this. So if I did a PPTT with XY over YW and XA over AT and replace AT with AY, then I would have what I have here. So we got parallel lines. So I have XY over YW is equal to XA over AT. So that's in the triangle XWT, that's a parallel proportion triangle theorem. And this big triangle with this line parallel to this one, the xy over yw is xa over at. Now, because I have angle 1 equals angle 2, which is given, that means, oops, that's number 4. That means I'm going to have ay equals at. And that's the converse of the ITT. Converse of ITT. So that's the converse of the isosceles triangle theorem. That's what the abbreviation means. Converse of the isosceles triangle theorem is going backwards. Converses, I have two angles equal, I have two sides equal. What is the ITT? The ITT says what? If these two sides are equal, then these angles are equal. And what's the converse? If these two angles are equal, that means the two sides are equal. So two equal angles, two equal sides. Two equal sides, two equal angles. Also, if you have three equal angles, you have three equal sides. Three equal sides gives you three equal angles. No sides equal, no angles equal. So trying to explain, look up congruent triangles. And as a result of AY equals AX, I can now replace AY, XY over YW is equal to XA. So instead of AT, I have AY. And that's a substitution. In other words, I'm taking AT out of here. That's a substitution. And some teachers say substitution. It's substituting 4 into 2. And that gives you this one. So 4. So AT is equal to AY. So replacing AT with AY. And that's the proof. Again, a few proofs on the triangle proportionality theorem and some working the values of x. If you like my video, click the like button, click the subscribe button, the notification bell. Visit my math website at www.mathfullyexplained.com, and there you will find more information about me, my videos, and my content. The content is on my YouTube channel called Math Fully Explained. Hope you enjoyed my video. Thank you very much. Bye-bye.